Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk a little bit about the differences in the effects of deep water waves and shallow water waves. Now, we're going to talk about these in general terms, but then also how things work a little bit in the software ProteusDS that we use and we develop, and then what kind of why you would want to know about this or be aware of this. So what I've done to demonstrate this is I've got two different projects that I've set up. Now I have a deep water case where we basically have 1,000 meters water depth, basically infinite water depth. And I've got two rigid bodies here with little spherical ellipsoid hulls. They're about a 1/4 meter diameter, so pretty small. This is just below the surface. This is about 5 meters down, and exactly the same thing here, with the only main difference being that it's in 10 meters water depth. So you can see the inputs that I have here. I had to sort of, it's kind of finicky to get it exactly neutrally buoyant. I had to play with this a little bit. I mean, part of the reason for this is the discretized hull that there is. It's not going to be a perfect sphere and so on. Anyway, in both of the cases, the waves are the same. They're pretty extreme, especially for such shallow water, but they're 5 meter wave height, that's trough to crest, and a single sinusoidal wave, an airy wave, and a 9-second period. So maybe you might be wondering, hey, why didn't you use a point mass? Well, we totally could have done that. There's a great feature in Proteus where we can show the position history. So you'll see the tails, which really illustrates what's happening. It doesn't do that with point masses. So anyway, we'll play these two cases here, and you see the waves ramping up, and we start seeing the position history for these. And I mean, ultimately, the big thing that happens here is in deep water, you get much more circular patterns of the wave particle velocities, and that creates motion and loads, drag loads, motion and loads on moorings, and anything that's like kind of floating in the water. Now, over on the shallow water case, things, ultimately the seabed really creates this compressing effect on the waves. It does affect the shape of the wave. And ultimately what happens is there's a way more surging back and forth effect in the flow under the water surface from the water particle motions. And you get this very much more elliptical pattern. You can see I haven't quite got things balanced perfectly. They're gradually kind of sinking over here. But, you see a much more circular trajectory and a much more elliptical trajectory. So, why does that matter? Well, if you have a mooring in more shallower water conditions, you could expect to see quite a big amplification of that back and forth drag loading and dynamics on the mooring. So just something to be aware of that might kind of give you a bit more intuition about how these kinds of systems might behave, whether it's a mooring or a vehicle or a floating structure like that. I guess maybe one thing to highlight here, if you're on the tree, you can right click and go display position history. That's how you can show these tails and sort of make a visual representation of where the rigid bodies are going. Yeah, all right, that's all I wanted to show for now. Thanks for watching.